On the 1st of September 1939, German armoured columns crossed into Poland with a speed and violence that stunned the world. The Wehrmacht deployed 2,750 tanks and 2,315 aircraft in the opening assault. Poland fielded 880 tanks, many obsolete, and 400 aircraft. The numerical advantage seemed decisive. But the disparity in equipment was only the beginning. Hidden beneath the spectacular triumphs of Blitzkrieg lay a crisis that would ultimately doom the German war machine. The Reich possessed almost no indigenous oil supply whatsoever. In 1939, Germany produced 1.8 million tons of petroleum domestically, whilst consuming 7.5 million tons annually. The remaining 5.7 million tons, 76% of total consumption, arrived from abroad. Romania supplied the largest share, followed by imports from the Soviet Union, Venezuela, and American companies operating through neutral nations. Every litre of aviation fuel that powered the Luftwaffe, every drop of petrol that filled Wehrmacht tank engines, every barrel of lubricating oil that kept machinery functioning came from beyond German borders. When Britain declared war on the 3rd of September 1939, the Royal Navy began a blockade that would cut Germany's maritime oil imports to virtually nothing within months. The mathematical impossibility became stark. The Wehrmacht needed millions of tons of fuel annually, yet Germany controlled no oil fields whatsoever. The man who would transform this desperate situation wasn't a chemist or petroleum engineer. Friedrich Bergius was born in 1884 in Goldschmieden, near Breslau, in what was then Prussia. His father owned a chemical factory, and young Friedrich showed early aptitude for science, but his path into industrial chemistry came through persistent curiosity rather than family expectation. He studied chemistry at the University of Breslau, then at Leipzig under Wilhelm Ostwald, one of the founders of physical chemistry. Bergius completed his doctorate in 1907 with research into the effects of high pressure on chemical reactions, work that seemed purely academic at the time. After university, he worked briefly at the Technische Hochschule in Hanover, then spent 2 years studying under Fritz Haber and Walter Nernst in Berlin, absorbing their pioneering work on high-pressure industrial processes. In 1909, Bergius established his own laboratory in Hanover, financed partly by his family's resources. He focused obsessively on a problem that obsessed Germany even then. The Reich had abundant coal, but almost no petroleum. Could coal be chemically transformed into liquid fuel? The question wasn't new. Chemists had theorized about coal liquefaction for decades, but practical success had remained elusive. Bergius approached it differently. He subjected powdered coal to extreme pressures, 200 atmospheres, and temperatures above 400 degrees Celsius in the presence of hydrogen gas and catalysts. The process was technically called hydrogenation. In 1913, after 4 years of experimentation and numerous failures, Bergius successfully converted coal into synthetic petroleum. The liquid that emerged from his pressure vessels could be refined into petrol, diesel, and aviation fuel, chemically identical to products derived from crude oil. The Bergius process represented a genuine breakthrough, but transforming laboratory success into industrial production required solving immense manufacturing challenges. The equipment needed to sustain 200 atmospheres of pressure whilst maintaining temperatures above 400 degrees Celsius didn't exist in 1913. Bergius designed custom pressure vessels, developed new catalyst formulations, and engineered heat exchange systems to manage the violent exothermic reactions. He secured patents across Europe and attracted investment from German chemical firms. In 1914, just as his work approached commercial viability, the First World War erupted. Germany's petroleum imports ceased almost immediately as the British blockade tightened. The military showed interest in Bergius's coal liquefaction, but scaling the process to meaningful production volumes proved impossible during wartime. Bergius lacked the capital. The specialized equipment manufacturers were occupied with munitions production, and the technical expertise required to operate high-pressure hydrogenation plants simply didn't exist amongst available workers. After Germany's defeat in 1918, Bergius continued refining his process throughout the 1920s. His work attracted attention from IG Farben, the enormous German chemical conglomerate formed in 1925. IG Farben possessed the capital, engineering expertise, and industrial infrastructure to scale coal liquefaction. They licensed Bergius's patents and began construction of the first commercial-scale hydrogenation plant at Lohna in central Germany. The Lohna facility commenced operations in 1927, producing 100,000 tons of synthetic fuel annually. Bergius received the Nobel Prize in Chemistry in 1931, sharing it with Carl Bosch for his contributions to high-pressure chemical processes. By the time Adolf Hitler assumed power in January 1933, Germany operated 4 coal hydrogenation plants with combined annual capacity of 800,000 tons of synthetic fuel. This represented substantial progress, but the Reich still imported 85% of its petroleum consumption. Hitler's strategic vision for German expansion required fuel self-sufficiency. In 1936, he announced the 4-year plan, demanding massive expansion of synthetic fuel production. The plan called for building new hydrogenation plants and increasing capacity at existing facilities. IG Farben received government contracts and subsidies to construct additional plants at Berlin, Magdeburg, Scholven, and elsewhere. By 1939, German synthetic fuel production reached 2.2 million tons annually, still inadequate for military requirements, but a significant increase. The Bergius process, combined with the Fischer-Tropsch method developed at the Kaiser Wilhelm Institute, allowed Germany to produce roughly 40% of its liquid fuel needs domestically. The remaining 60% came from imports, primarily Romanian crude oil arriving via the Danube and Soviet petroleum delivered under trade agreements. When Germany invaded Poland in September 1939, Wehrmacht planners calculated fuel consumption rates with grim precision. The Polish campaign consumed 600,000 tons of fuel in 5 weeks. The Norwegian campaign in April 1940 required 350,000 tons. The invasion of France and the Low Countries in May 1940 burned through 2.4 million tons in 6 weeks. These early Blitzkrieg victories succeeded partly because they concluded quickly, before fuel shortages could cripple operations. German synthetic fuel plants operated at maximum capacity, producing 72,000 tons weekly by mid-1940. IG Farben employed 87,000 workers across its hydrogenation facilities. The plants ran continuously. Coal liquefaction required maintaining constant pressure and temperature. Shutdowns meant days of costly restart procedures. The military demanded more. In July 1940, Hitler ordered preparations for Operation Barbarossa, the invasion of the Soviet Union. Wehrmacht quartermaster projections estimated the campaign would require 8 million tons of fuel over 4 months. German stockpiles in June 1941 totaled 2.4 million tons. Synthetic production could deliver perhaps 3 million tons during the campaign period. That left a shortfall of 2.6 million tons, a deficit that could only be addressed by capturing Soviet oil fields in the Caucasus region near Baku, which produced 80% of Soviet petroleum. The entire strategic concept of Barbarossa depended on reaching those oil fields before German fuel reserves ran dry. Operation Barbarossa commenced on the 22nd of June, 1941. 3 million German soldiers, 3,600 tanks, and 2,700 aircraft surged eastward. The initial advances matched Blitzkrieg expectations. Hundreds of kilometers penetrated in weeks, massive encirclements, spectacular tactical victories. But fuel shortages began hampering operations almost immediately. Panzer divisions outran their supply lines. Luftwaffe squadrons received reduced fuel allocations, limiting sorties. By August, frontline units reported tanks immobilized for lack of petrol, whilst Soviet forces escaped encirclement. The Wehrmacht never reached the Caucasus oilfields in 1941. Army Group South advanced to Rostov, but was driven back. The winter offensive ground to a halt, and with it died any hope of fuel self-sufficiency through conquest. German synthetic fuel plants continued maximum production throughout 1942, delivering 4.9 million tons. Romania supplied another 3.2 million tons. Total availability reached 8.1 million tons, barely adequate for defensive operations, wholly insufficient for renewed major offensives. The 1942 summer campaign focused obsessively on the Caucasus. Hitler committed Army Group South to a drive toward Baku, overruling military objections about overextended supply lines. The offensive reached Stalingrad and pushed into the Caucasus foothills near Grozny, but never captured the critical oil fields. By November 1942, the Sixth Army was encircled at Stalingrad, and German forces in the Caucasus withdrew to avoid being cut off. The failure to secure Soviet oil supplies meant Germany would fight the remainder of the war with inadequate fuel. The crisis intensified in 1943 as Allied strategic bombing turned toward German synthetic fuel plants. On the 12th of May 1944, the United States 8th Air Force and RAF Bomber Command commenced Operation Point Blank, specifically targeting hydrogenation facilities. The Leuna plant, which produced 600,000 tons annually, nearly 12% of total German synthetic fuel, was struck repeatedly. On the 19th of May, 800 American heavy bombers attacked Leuna, dropping 1,600 tons of explosives. The facility ceased production entirely. Repairs took 6 weeks. The plant restarted in early July, only to be bombed again on the 20th of July. This pattern repeated throughout the summer. Attacks, damage, frantic repairs, resumed production. More attacks. Workers at Leuna toiled in brutal conditions to maintain output. The plant employed 13,500 workers by 1944, including thousands of forced laborers and concentration camp prisoners. Anna Fischer, a German chemical engineer transferred to Leuna in March 1944, later recalled the relentless pressure. "We worked 12-hour shifts whilst the bombs fell. The pressure vessels couldn't be shut down without losing weeks of production, so we kept the hydrogenation running even during raids. My supervisor told me, 'Every litre you produce keeps a fighter aircraft in the sky.' I believed we were defending Germany. The moral complexity came later. The bombing campaign devastated German fuel production. Monthly synthetic fuel output dropped from 410,000 tons in April 1944 to 107,000 tons in September, a 74% reduction. By December, production fell to just 26,000 tons monthly, barely 6% of April levels. The Luftwaffe, which consumed 160,000 tons of aviation fuel monthly, received allocations of 30,000 tons by autumn 1944. Pilot training virtually ceased. Fighter squadrons were grounded for lack of fuel. In September 1944, Luftwaffe commander Hermann Göring admitted in a conference that fuel shortages had become the decisive limiting factor on German air operations. The Wehrmacht fared no better. German armoured divisions received 30% of their nominal fuel allocations by late 1944. Tanks were increasingly used as stationary pillboxes rather than mobile assault weapons because movement consumed irreplaceable fuel. During the Ardennes offensive in December 1944, Hitler's final gamble in the West, panzer divisions launched their attack with enough fuel for perhaps 100 kilometers of advance. The operational plan explicitly assumed capturing American fuel dumps to sustain the offensive. When this failed, German tanks ran dry within days. The 2nd Panzer Division reached Zels, just 8 kilometers from the Meuse River, before immobilization from fuel exhaustion. Crews abandoned their vehicles and retreated on foot. American forces captured 88 German tanks at Sels, most undamaged but empty. The contrast with Allied fuel availability was crushing. By 1944, American refineries produced 234 million tons of petroleum products annually. The United States supplied not only its own military, which consumed 40 million tons in 1944, but also provided substantial quantities to Britain, the Soviet Union, and other Allied nations through Lend-Lease. American tanker fleets delivered fuel across the Atlantic, despite U-boat threats. By mid-1944, Allied forces in France consumed 12,000 tons of fuel daily, more than total German weekly synthetic production. The logistical disparity rendered German resistance ultimately futile, regardless of tactical skill or battlefield courage. Germany's synthetic fuel program did achieve remarkable technical success within its constraints. The Bergius hydrogenation process and Fischer-Tropsch synthesis represented genuine innovations in chemical engineering. At peak capacity in early 1944, German plants produced 5.5 million tons of synthetic fuel annually from coal, a substantial achievement in applied chemistry. But the fundamental strategic problem remained insoluble. Germany lacked petroleum reserves, failed to capture major oil fields, and faced enemies with effectively unlimited fuel supplies. The bombing campaign against synthetic fuel plants, whilst costly in Allied aircrew lives, the raids on Luna alone cost 147 bombers and nearly 1,500 airmen killed or captured, achieved devastating strategic effect. Every ton of synthetic fuel production destroyed forced German forces into greater immobility, reduced training hours for pilots, and limited armored maneuvers. The mathematical impossibility that confronted Germany in 1939 ultimately reasserted itself. The nation needed millions of tons of fuel annually, whilst controlling no oil fields and facing blockade. Synthetic production, even at maximum capacity, covered only half of military requirements. Romanian imports provided temporary relief, but never adequate quantities. The Soviet oil fields remained beyond reach. American petroleum overwhelmed German alternatives. Friedrich Bergius did not witness the final collapse of the synthetic fuel program he pioneered. He fled to Argentina in 1945 as Allied forces advanced, working briefly as an industrial consultant before his death in Buenos Aires in March 1949, aged 64. His legacy remained complex. The coal hydrogenation process he developed enabled Germany to sustain military operations years longer than petroleum dependency alone would have permitted. Yet the fundamental resource insufficiency doomed those operations regardless. Modern chemical engineering recognizes the Bergius process as a milestone in high-pressure catalytic chemistry, though petroleum refining from crude oil remained far more economical once global oil production expanded after 1945. The historical irony cuts deeper when examining post-war petroleum geopolitics. The vast Middle Eastern oil fields that would dominate global supply for the next 70 years lay largely undeveloped during the Second World War. Saudi Arabia produced just 60,000 tons annually in 1939. Iraq, Iran, and Kuwait combined output barely exceeded 15 million tons. Had Germany somehow secured access to these reserves, the strategic calculus would have shifted entirely. But British control of the region, American development of Saudi fields, and geographic distance placed these resources forever beyond German reach. The Blitzkrieg succeeded whilst fuel lasted. Poland fell in 5 weeks, France in 6. When fuel supplies constrained operations, German offensives stalled regardless of tactical brilliance. The Wehrmacht never solved the fundamental equation. Wars of mobility require fuel, and Germany possessed almost none. Every spectacular tank advance, every Luftwaffe sortie, every mechanized breakthrough consumed irreplaceable petroleum drawn from stockpiles that could never be adequately replenished. The mathematics were brutal from the start. In the end, German engineering came in second place to simple resource availability.